Bismillahirrahmanirrahim. Exercise 2.5, question number 1. We are going for part 4. The given function is cos of x square. So let's take y equals to x square. Replace x by x plus del x, y by y plus del y. Bring this y over here. Put y equals to cos of x square. And meanwhile, also open up this bracket. X plus del x whole square becomes x square plus 2x del x plus del x square. Now we have here cos of this minus cos of this. That is cos minus cos. So we are going to use the formula of cos p minus cos q, which is equal to minus 2 sine of p plus q by 2 sine of p minus q by 2. In place of p we have this, and in place of q we have only x square. So let's apply that formula. And we get this expression del y is equal to minus 2 sine of x square plus 2x del x plus del x square plus x square by 2 x square plus 2x del x plus del x square minus x square by 2 sine of both the angles. So let's simplify it. This x square and x square got cancelled. This x square got added to this x square and we have this shape. Del y is equal to minus 2 sine of 2x square plus 2x del x plus del x square by 2 and sine of 2x del x plus del x square. You can see we can take a del x common from here. So we write it like this, and we have similarly we go at the end. The meanwhile we also go for the next step. And what is the next step of derivative? That is we have to divide both the sides by del x. So we have done two things. We have taken this del x common and this expression takes this shape, and we have divided both the sides by del x. You can see we have divided by del x on left side and we have divided by del x on right side. Now what we are going to do, we are going to multiply this del x by 2x plus del x. So when we multiply this del x, we also have to divide by 2x plus del x. So we multiply and divide the whole right hand side by 2x plus del x. Here it is. You can see del y by del x is equal to minus 2x plus del x. 2x plus del x, we multiply and divide by this. This del x were already there. All the other things were already there. Now what we are going to do now? We are going to write this 2x plus del x into del x, and this 2 we are going to write it below it, and then we are going to write this whole expression under this sign, so that this whole angle becomes under the sign. Let's see. You can see it here. This 2x plus del x into del x, it is here, and this 2 is under this. You can see it here. What is the advantage of writing it like this? It has got the shape of sine theta by theta, where theta is equal to 2x plus del x into del x by 2. And you can see that as del x tends to 0, this 2x plus del x into del x by 2 tends to 0. So when we apply the limit, when del x tends to 0, this whole expression will become 1. And this is our next step. We are going to apply the limit when del x tends to 0, and we are going to apply the limit here and here and here and here. Let's apply the limit when del x tends to 0. Limit when del x tends to 0 of del y by del x minus limit when del x tends to 0 of 2x plus del x into limit when del x tends to 0 of sine of this whole expression into limit when del x tends to 0 of sine of 2x plus del x into del x by 2 divided by 2x plus del x into del x by 2. You can see it is in the shape of sine theta by theta, and when del x tends to 0, this whole expression becomes 0. So this whole limit becomes 1. And we are going for our answer now. We were going to apply the limit. This will become 1. What happens here? This becomes 0. This becomes 0. This remains as it is. What happens here? This becomes 0. And what happens here? This becomes dy by dx. You can see dy by dx is equal to minus as it is. and this becomes 2x plus 0 into sine of 2x square plus 0 by 2, 0 and 0 here. Here it is, into this whole limit becomes 1. And what is the final result? This 2 and this 2 got cancelled, and we have the answer, which must be minus 2x into sine of x square. You can say it. The derivative is minus 2x sine of x square, and this is the answer. Let's get to part 5 is tan square x. Let's start the solution. Let's take it equal to y. Y equals to tan square x. First step, y plus del y equals to tan square of x plus del x. Then bring y towards right hand side. Then put y equals to tan square x. And what do you see? The formula of a square minus b square. So write it in the shape of a plus b into a minus b. This is in place of a and this is in place of b. This is what we get. Tan of x plus del x plus tan of x into tan of x plus del x minus tan of x. Leave this plus expression as it is. This will go to the answer. We are not going to make any change in it. But what about this negative expression? We are going to convert it into sine by cos, both the tan into sine by cos. So let's convert this tan into sine by cos, this tan into sine by cos. What shape it becomes? Del y is equal to, you can see this expression is as it is. And what about this one? This becomes sine of x plus del x by cos of x plus del x, and this becomes sine of x by cos of x. Now you can see we can take LCM, so we are going to take LCM. So del y is equal to, you can see this expression is unchanged. And what happens here? When we take the LCM, we see the formula of sine alpha cos beta minus cos alpha sine beta. That is the formula of sine of alpha minus beta, where we have this in place of alpha and this in place of beta. So what we are going to get? We are going to get it as sine of alpha minus beta. That is sine of x plus del x minus x. You can see it here. Del y becomes tan of x plus del x plus tan x. This expression is unchanged, and this becomes sine of x plus del x minus x divided by cos of x plus del x into cos of x. This x got cancelled, and our result takes this shape. Now we can go for our next step of derivative, which is dividing both the sides by del x. So we will divide this by del x, we will divide this by del x. Here it is, dividing both sides by del x. Next we are going to rearrange. For how we are going to rearrange? We are going to put this del x below this sine del x, and we are going to write these two terms together. You can see it here. And now what? Apply the limit. When del x tends to 0, you will write limit when del x tends to 0 here, limit when del x tends to 0 here, limit when del x tends to 0 here. This will become, here you can see limits are applied. This big limit becomes dy by dx. What happens to this one? Just put a 0 here, just put a 0 here. That is it. And what happens to this one? This is simply limit when theta tends to 0 sine theta by theta. So this limit is just equal to 1. So here it is. Tan x plus 0 becomes tan x plus tan x. Cos x plus 0 becomes cos x into cos x. So here it is. Dy by dx is equal to tan x plus tan x by cos x into cos x whole multiplied by 1. And what is the final result? This becomes 2 tan x and this becomes cos square x. You can write cos square x is in the denominator. You can break it into the numerator by writing secant square x, and we have the final result. The derivative is equal to 2 tan x into secant square x, and that is the answer.